Hello, in this lecture we will find the value of DE. In the drawing we have triangle ABC. We know that AC equals to 2 units, BC equals to 8 units, and we also know that line segment DE is parallel to AB, and point G is the centroid of triangle ABC. The centroid of a triangle is a point where the three medians of the triangle are intersect with each other, and we want to find out the value of DE, or the size of DE, and we also know that DE belongs to the natural numbers. That is to say that DE is a natural number, or the size of DE is a natural number. And we want to find out the value of DE. So, first of all, we have a rule that relates to the centroid of a triangle. So, if we have a triangle ABC, that can be any triangle, and we know that side AB is the size of side AB is A units, the size of side AC of triangle ABC is equal to B units, and the size of side BC is C units. And we actually know that the centroid of the triangle is at point G, and AD is the median of triangle ABC. That is to say, AD bisects side BC, or AD divides side BC to two equal parts. That is to say, BD equals to DC. Then that is the rule that applied to any triangle. So it is in any triangle. Actually, the centroid at point G divides the median AD in a relationship that equals to 2 to 1. That is to say that if AG equals to 2 units, then GC will be equal to 1 unit, or in other words, AG is twice as large as CG. So we can write down that AG equals to 2 times AC. Okay? So actually, the median AD is divided by the centroid G in a relation to 2 to 1. That is to say, AG is twice as large as CG. or AG equals to 2 times AG equals to 2 times GD. Again, AG equals to 2 times GC. So I write it again. AG equals to 2 times GC. Okay, AG equals to 2 times GC. AG is twice as large as GC. So we actually can implement this rule in our triangle, because in our triangle we have point G that is the centroid of triangle ABC. Therefore, according to the rule that I mentioned, the centroid G divides the median CF in a relationship to 2 to 1. That is to say that if CG equals to 2 units, then GF will be equal to 1 unit. Or we can write down that CG equals to 2 times GF. Okay, CG equals to 2 times GF because the centroid G divides the median CF in a relationship to 2 to 1. That is to say, CG is twice as large as DF, or CG equals to 2 times GF. And if we define CG as 2x, that is to say, if CG equals to 2x, CG equals to 2x, so we can substitute CG in this equality by 2x. We will get that 2x equals to 2 times GF. We will divide this equality by 2 and we will get that GF equals to x. So we actually found out that if CG equals to 2x, then GF will be equal to x. Okay, so if CG equals to 2x, then GF will be equal to x. Okay, and we actually have another rule that is also applied in any triangle. If we have triangle ABC that could be any triangle, and we know that line segment DE, this line segment is parallel to BC. If we know that line segment DE is parallel to BC, then the following relationship exists between the sides of the triangle AD over DB will be equal to AE over EC. So I will repeat again. That is also true for any triangle. So in any triangle, in any triangle, triangle ABC can be any triangle if we know that line segment DE is parallel to BC, then the following equality is true. AD over DB equals to AE over EC. And again, we can also implement the second rule in our drawing, because in our drawing we know that DE is parallel to AB. DE is parallel to AB. And if we relate to triangle ACF, if we relate to this triangle ACF, so in triangle ACF, because of the fact that DE is parallel to AB, according to this rule, we can say that CD over AD equals to CG over GF. Again, in triangle ACF, because of the fact that DE is parallel to AB, according to the rule that I mentioned, the following relationship is true, that CD over AD will be equal to CG over GF. Okay? But what is the value of CG? CG equals to 2x. And what is the value of GF? GF equals to x. So in total we got that CD over AD equals to 2x over x. X over x is 1, so in total we will get that CD over AD equals to 2. Because x will get cancelled. So we found out that CD over AD equals to 2. So here we will multiply this equality by AD and we will get that CD equals to 2 times AD. Okay? And if we define CD as 2y, if CD equals to 2y, then we can substitute the value of CD by 2y, because CD equals to 2y, and we will get that 2y equals to 2 times AD. Two y equals to 2 times AD. We will divide this equality by 2 and we will get that AD equals to y. So we actually found out that if CD equals to 2y, then AD will be equal to y. So we can write here that if CD equals to 2y, then AD or DA equals to y. Okay? So we actually have another rule. The rule states that corresponding angles between parallel lines are equal to each other. We write it down. We write down the rule. The rule states that corresponding angles between parallel lines are equal to each other. So I will read the rule again. The rule states that corresponding angles between parallel lines are equal to each other, and again we can implement this rule in our drawing because we know that in our drawing DE is parallel to AB. DE is parallel to AB, therefore the corresponding angles will be equal to each other. Those two corresponding angles that are located between parallel lines will be equal to each other. Okay, so if angle BAC equals to alpha, then angle CDE will be also equal to alpha because of the fact that those two angles are corresponding angles that are located between parallel lines. That is to say, DE is parallel to AB, therefore they are equal to each other. Okay, so we can write down that angle BAC, this angle, equals to angle CDE, and both those two angles are equal to alpha. Okay, so according to the rule that corresponding angles between parallel lines are equal to each other, angle BAC equals to angle CDE, and if one of the angles is alpha, then the other angle will be equal to alpha. Okay, and the same thing we can say about the other side of the triangle. Here we have two angles, this angle and this angle. Those two angles are located between parallel lines. Line DE is parallel to line AB. So they are located between parallel lines, and according to the rule that corresponding angles between parallel lines are equal to each other, those two angles will be equal to each other. So if angle ABC equals to beta, then angle CED will be also equal to beta because of the fact that those two angles are equal to each other. So I will write it down. Angle ABC, this angle, equals to angle DEC, and both those two angles are equal to beta. Okay, angle ABC equals to angle DEC, and both those two angles are equal to beta. So both those two angles are equal to each other, and they are both equal to beta. Okay, so we found out that those two angles are equal to each other and they are equal to alpha, and those two angles are also equal to each other and they are equal to beta. So in the next step we will focus on triangles ABC. And triangle CDE. So on those two triangles, we know that angle BAC, this angle, is equal to angle EDC, this angle and both those two angles are equal to alpha. Okay, so angle BAC in triangle ABC is equal to angle EDC in triangle EDC, and both those two angles are equal to alpha. And we also know that angle ABC, this angle, is equal to angle DEC, this angle, and both those two angles are equal to beta. Okay, so angle ABC equals to angle DEC, and both those two angles are equal to beta. And here we have a common angle. Angle C is a common angle because it belongs to both triangles. So we can write down that angle C equals to angle C. As a common angle, it belongs to both triangles. It belongs to triangle ABC, and angle C also belongs to triangle CDE. So it is a common angle. Okay, angle C equals to angle C. So we actually found out that all the angles of triangle ABC are equal to all the angles of triangle CDE. Therefore, we actually proved that triangle ABC is similar to triangle CDE according to angle rule. So I'll write it down. We actually proved that triangle ABC is similar, that is the sign of similar, to triangle CDE according to angle similarity rule. Okay, so what is angle similarity rule? Actually, if you prove that three angles of one triangle are equal to three angles of another triangle, then you prove that those two triangles are similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle CDE, the following relationship exists between the sides of the two similar triangles. Actually, CD over AC, or CD over CA, will be equal to DE over AB. So I will repeat again. Because of the fact that triangle ABC is similar to triangle CDE, the following relationship exists between the sides of the two similar triangles. CD over CA equals to DE over AB. Okay? CD over CA equals to DE over AB. But what is the value of CD? CD equals to 2y. And what is the value of CA? CA equals to CD plus DA. That is to say, CD equals to 2y plus y. Okay, so we found out that 2y over 3y equals to DE over AB. So I write it down. 2y over 3y equals to dE over AB. Y over y is 1, so y will get cancelled. So, and we left only with 2/3. 2/3 equals to dE over AB. So here we will multiply this equality by AB, and we will get that dE equals to 2/3 AB. So we found out that dE equals to 2/3 AB. Okay? dE equals to 2/3 AB. So we actually have another rule that is true in any triangle. In any triangle, so we actually if we have triangle ABC, that could be any triangle, and we know that side AB, the size of side AB is A units, the size of side AC of triangle ABC is B units, and the size of side BC of triangle ABC is C units. Then actually the rule states that the length of the sum of two sides on a triangle is always will be bigger than the length of the third side. That is to say, C will be smaller than A plus B. That is from one side. And the second thing that this rule states that the difference between two sides in any triangle will be always smaller than the length of the third side. That is to say, C will be always bigger than A minus B, or the absolute value of A minus B. Okay, so the rule states that C, that is to say the size of BC, that is C, will be smaller than A plus B from one side, but C is bigger than the absolute value of A minus B. Okay? That is the rule. And again, we can implement the rule in our triangle ABC. So in our triangle ABC, according to the rule that I stated, AB in triangle ABC, with the size of AB or AB is smaller than AC plus CB, AC plus CB, and AB is bigger than AC minus CB, or the absolute value of AC minus CB. Okay, so actually this inequality is the implementation of this rule in our triangle, in our specific triangle ABC. AB is smaller than the sum of the other two sides, and AB is bigger than the difference between the two other sides of the triangle ABC. Okay, but we also know, that CA equals to 2 units, or AC equals to 2 units, and CB equals to 8 units. Okay, so AB so we will get that AB is bigger than the absolute value of 2 minus 8, and it is smaller than 2 plus 8. Or AB is smaller than 10, and it is bigger than the absolute value of minus 6. 2 minus 8 is minus 6. The absolute value of any number is the distance of the number from 0. The distance of minus 6 from 0 is 6 units. Therefore, the absolute value of minus 6 is 6. So we got that AB is smaller than 10 and it is bigger than 6. Okay, but we have already found out that the value of DE is 2/3 times AB. Okay, so here we will multiply this inequality by 2/3, and we will get that 2/3 times AB equals to is smaller than 2/3 times 10, and it is bigger than 2/3 times 6, but we know that 2/3 AB equals to DE, so we can substitute 2/3 AB by DE, and we will get that DE is bigger than 2 times 6 is 12, and 12 over 3 is 4. So DE is bigger than 4, and it is smaller than 2 times 10 is 20, is 20, and 20 over 3 is 6.66. So we found out that DE is smaller than 4, and it is smaller than 6.66, and it is smaller than 4. But we also know it is given us in the question that DE belongs to the natural numbers. That is to say, DE is a natural number. We know that DE belongs to the natural number. So which natural numbers we have that are bigger than 4 and smaller than 6.66? Actually, the only two natural numbers that are bigger than 4 and smaller than 6.66 are 5 and 6. So we actually found out that the value of DE, or the size of line segment DE, equals to either 5 units or 6 units. So the answer to the question is the size of line segment DE. This line segment is either equals to 5 units or 6 units. And that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the value of DE. We know that AC equals to 2 units. We also know that BC equals to 8 units. And we know that DE is parallel to AB. And DE is a natural number. And we also know that point G is the centroid of triangle ABC. So what is the centroid? Centroid is the point where the three medians of the triangle are intersect with each other. Okay, again, the centroid G is the point where the three medians of the triangle are intersect with each other. And we have a rule that relates to a median of a triangle. In any triangle, if G is the median of triangle ABC, that can be any triangle, and AD, if G is the centroid of triangle ABC, and AD is the median of triangle ABC, that is to say, it bisects BC, or it divides BC to two equal parts, that is to say BD equals to DC, then the centroid G divides the median AD in a relationship that equals to 2 to 1. That is to say, if AG equals to 2 units, then CG will be equal to 1 unit. Okay, if AG equals to 2 units, then GC will be equal to 1 unit. Therefore, actually, AG is twice as large as CG, or we can write down that AG is 2 times GC. Okay, and if we define GC or CG, so we know that CG equals to so actually we can implement, so we know here that AG equals to 2 times CG, and we can implement this rule in our drawing, because we know that in our drawing we have G, that is the centroid of triangle ABC. Therefore, the centroid G divides the median CF in a relationship that equals to 2 to 1. That is to say, if CG equals to 2 units, then GF will be equal to 1 unit. Or, in other words, CG equals to 2 times GF. Again, CG equals to 2 times GF. And if we define CG as 2x, that is to say CG equals to 2x, so we will substitute CG by 2x, because CG equals to 2x. We will get that 2x equals to 2 times GF. We will divide this equality by 2, and we will get that GF equals to x. So we found out that if CG equals to 2x, then GF will be equal to x. So here we can write down that if CG equals to 2x, then GF will be equal to x. Okay? And we have another rule that it is true in any triangle. If we have triangle ABC, that could be any triangle, and we know that DE is parallel to BC, then the following relationship exists between the sides of the triangle. AD over DB will be equal to AE over EC. Okay? If we know that in triangle ABC DE is parallel to BC, then the following formula is true, that AD over DB equals to AE over AC. AD over BD equals to AE over AC. And again, we can implement this, the second rule, in our drawing, because in our drawing we know that DE is parallel to AB. It is given us in the question that DE is parallel to AB. So if we relate to triangle ACF, this triangle, we know that DE is parallel to AF, so according to the rule that I mentioned, CD over AD will be equal to CG over GF. Okay, so in triangle ACF, because of the fact that DE is parallel to AB, we can write down that, according to the rule that I mentioned, that CD over AD equals to CG over GF. Okay, but what is the value of CD? CD equals to 2y. And what is the value of AD? AD equals to y. Actually we have this rule that in triangle ACF, because of the fact that DE equals to AB, then CD over AD equals to CG over GF. Okay, and what is the value of CG? The value of CG is 2x. So we can write here CG equals to 2x, and the value of GF is x. So we can write down here that GF equals to x. CG equals to 2x and GF equals to x. So 2x over x is 2. So we actually found out that CD over AD equals to 2. And if we multiply this equality by AD, we will get that CD equals to 2 times AD. That is to say, CD is twice as large as AD. So if we define CD as 2y, that is to say CD equals to 2y, so we'll substitute CD by 2y, because CD equals to 2y, we will get that 2y equals to 2 times AD. We will divide this equality by 2 and we will get that AD equals to y. So we found out that if CD equals to 2y, then AD will be equal to y. So here, if CD equals to 2y, then AD equals to y. Okay? Then we actually have another rule. The rule states that corresponding angles between parallel lines are equal to each other. Okay? And we know that line DE is parallel to line AB. So we have here two corresponding parallel lines. We know that line DE is parallel to line AB. Therefore, according to the rule that I mentioned, the corresponding angles will be equal to each other. Those two corresponding angles will be equal to each other. That is to say, angle. So if one angle equals to alpha, then the other angle will be equal also to alpha. So the corresponding angles are equal to each other. That is to say, angle BAC will be equal to angle CDE will be equal to alpha. Why? Because those two angles are corresponding angles that are located between parallel lines, therefore they are equal to each other. And the same thing we can say about the other side of the triangle. We have between the two parallel lines, DE is parallel to AB, and we have between those two parallel lines two corresponding angles. Those two angles are corresponding angles that are located between parallel lines, therefore they are equal to each other. Therefore, if one of them is equal to beta, then the other will be also equal to beta. That is to say, angle ABC will be equal to angle DEC, and both of them will be equal to beta. Then we actually proved that triangle ABC, the big triangle, is similar to triangle CDE. Okay? Why? Because those two angles are equal to each other and they are both equals to alpha. Angle BAC equals to angle EDC equals to alpha. So angle BAC in triangle ABC equals to angle EDC in triangle EDC, and they are both equal to alpha. And we also know that those two angles are equal to each other. That is to say, angle ABC in triangle ABC is equal to angle EDC in triangle EDC, and they are both equal to beta. And we have the third angle, angle C. Angle C is a common angle because it belongs to both triangles. So angle C is equal to angle C. It's a common angle. Angle C belongs to triangle EDC, and angle C also belongs to triangle ABC. So it is a common angle, and so we can write down that angle C equals to angle C. So we actually proved that the three angles of triangle ABC are equal to the three angles of triangle CDE, and therefore those two triangles are similar to each other according to angle similarity rule. So angle similarity rule is a rule that states that if you prove that three angles of one triangle are equal to three angles of the other triangle, you proved that those two triangles are similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle CDE, we can deduce that CD from triangle CDE over AC from triangle ABC is equal to DE from triangle CDE over AB from triangle ABC. Okay? The following relationship is true because of the fact that triangle ABC is similar to triangle CDE. CD over CA equals to DE over AB. But what is the value of CD? The value of CD equals to 2y. CD equals to 2y. And what is the value of AC? AC equals to DC plus AD. That is to say, AC equals to 2y plus y. Okay? So, CD equals to 2y and CA equals to 2y plus y. So in total we got that 2y over 3y equals to DE over AB. 2y over 3y is 2/3. We got that 2/3 equals to DE over AB. We multiplied this equality by AB and we got that DE equals to 2/3 AB. Okay? Then we have the last rule. The last rule is true in any triangle. Actually, the rule states that the sum or the length of the sum of the two sides in any triangle is always will be greater than the length of the third side from one side, but the difference between any two sides in any triangle will be always smaller than the length of the third side. Okay, so that is to say, the size of BC is C units, the size of AB is A units, and the size of AB is B units. So C will be smaller than A plus B from one side, but C will be bigger than A minus B. Okay? And again, we can implement the rule in our triangle ABC. If we relate to AB, we can say that the size of AB will be smaller than the sum of the size of AC plus BC. AB will be smaller than AC plus B from one side, but AB will be greater than AC minus CB. AB will be greater than the absolute value of AC minus CB. Okay, that is the implementation of the rule that I mentioned in our triangle ABC. But we know that AC equals to 2 units and BC equals to 8 units. So we get here AC is 2 and CB is 8. And AC is 2, CB is 8, so it is 2 plus 8. 2 minus 8 is minus 6, and 2 plus 8 is 10. So we got that AB is greater than the absolute value of minus 6, and it is smaller than 10. What is the absolute value of any number? The absolute value of any number is the distance of the number from 0. The distance of minus 6 from 0 is 6 units. So the absolute value of minus 6 is 6. So we got that AB is greater than 6 and it is smaller than 10. So here we will multiply this inequality by 2/3. And we will get that 2/3 AB will be equal to 2/3 times 6 will be greater, 2/3 AB will be greater than 2/3 times 6, and it will be smaller than 2/3 times 10. And we also know that DE equals to 2/3 AB. Therefore we can substitute 2/3 AB by DE, because DE equals to 2/3 AB. So we substituted 2/3 AB by DE, and we got that DE is greater than 4 and it is smaller than 6.66. But we also know it is given us in the question that DE is a natural number. So which natural numbers we have that are greater than 4 and that are smaller than 6.66? We have only 2 natural numbers. That is to say, only 5 and 6 are greater than 4, and only the only natural number that we have, they are 5 and 6. Only the 2 natural numbers 5 and 6 are greater than 4 and smaller than 6.66. So we found out that the value of DE is either 5 units or 6 units. So the answer to the question is that the size of DE is either 5 units or 6 units. Okay, or the size of line segment DE is equal to either 5 units or 6 units. And that is the answer to the question. Okay, thank you very much.